So today we're going to look at the factoring method number 4, which is the difference of squares. And just a reminder here, while I hope that the smartboard doesn't stay pink, that we started off with greatest common factor, and greatest common factor applies to all of the methods, so that could still show up here in the difference of squares. Our second method was factoring by grouping, and we can distinguish grouping when we have 4 terms. Then our third method was split the middle. We can distinguish split the middle with 3 terms. And today, difference of squares is going to be 2 terms. Now the thing is, greatest common factor applies to them all. So if we see 4 terms, we could still have a greatest common factor. If we see 3 terms, we could still have a greatest common factor. If we see 2 terms, we could still have a greatest common factor. But in math, the other thing that we need to know about this is that difference means the answer to a subtraction problem. So when we're dealing with the difference of squares, we need to have subtraction somewhere in the problem. 2 terms and subtraction. Now my last statement, I'm not going to linger on. I think it'll show up better in the examples than it does over here. But we're working with square roots when we're dealing with this. And I actually sometimes talk about square roots and I sometimes don't talk about square roots. But ultimately, since it's the difference of squares, square means times itself. So what we're doing is we're taking the square root to be able to get our factors in our factoring process here. So you have the practice worksheet already. Gonna look at the 3rd column on your paper. And our directions tell us that we're going to factor each polynomial if possible. If the polynomial cannot be factored, we're going to write prime. So first of all, again, with difference of squares, we need to have 2 terms, which we do. X squared is a term, 64 is a term, and we need to have a minus sign. If we have that, we can factor this expression into 2 parentheses. And as we take a look at this here, what we're doing is we're taking the square root of x squared, which is x, and we're taking the square root of 64, which is 8. But oftentimes how I refer to it, even though that's what we're doing, is I say, well, what times itself equals x squared? Well, x times x is x squared. And it's the same thing with 64. What multiplied by itself equals 64? Well, 8 times 8 is 64. But again, ultimately what we just did is we took the square root of x squared to get x. We took the square root of 64 to get 8. And we're going to have the same values in each parentheses with our difference of squares method. The difference is different signs. One parenthesis is going to have a minus sign. One parenthesis is going to have a plus sign. I tend to write the minus sign first. Up to you. It does not make any difference if you write the plus sign first and the minus sign second. Again, looking at the 3rd column on this paper, 100r squared minus 9. Well, when we take a look at this one, we have 2 terms. 2 terms, we start to think about difference of squares, and a minus, and then we'll start with the 2 parentheses. When we take the square root of 100, the square root of 100 is 10. So 10 times 10 is 100. Because we want the same values in both parentheses, well, we can take the square root of r squared, it's r. And if you don't like r, use x. It's not going to make any difference. There are a lot of different variables on this paper. Square root of 9? Well, 9 is 3 times 3. And then finally, difference between two squares, different signs. And we factored this. By the way, if we double distributed or we multiplied these two parentheses together, we would end up with 100r squared minus 9. Problem number 9. 1, 2 terms and a minus sign. It's in a different place, but we can still use this to factor the difference of squares. Now, what may work better for us is if we write this as a subtraction problem. So what if we switched it around and wrote 81 minus r squared s squared? Still has 2 terms, still has a minus sign in it. I don't often switch the order, but I do personally like to have the minus sign in between the 2 terms. It's a personal preference, it does not have to be there. Once we have 2 terms and a minus sign, we start to think that we've got the difference between 2 squares. So what we're going to do is we're going to take the square root of 81. 9 times 9. We're going to take the square root of r squared. Well, that's r times r. Square root of s squared is s times s. Difference between 2 squares, different signs. By the way, if you're working ahead on the video, if you're working ahead in class, your other option here would be this. It would be negative rs plus 9, and then positive rs plus 9. That second option is still the same as the first option. It's just without changing the order around. Problem 12. Once again, the pattern here is that we look. Do we have 2 terms? By the way, the technical term for 2 terms is binomial. And do we have a minus sign? And the answer is yes to both of those. So we're going to start with our 2 parentheses, and then we're going to break it apart. Square root of 36, or what times itself equals 36? 6 times 6. Square root of j squared. Well, j times j is j squared. 49 is 7 times 7, or the square root of 49 is 7. M squared is m times m. Difference between 2 squares, different signs. I tend to write the minus sign first. Another Algebra 2 teacher might write the plus sign first. It does not make any difference. Notice the same values in each parentheses, just different signs. Now, when we look at problem number 15, we technically could do the difference of 2 squares because we've got 2 terms and a minus sign already. But there's a greatest common factor in this particular problem. And it's harder on these types of problems to see the greatest common factor in the answer. So we need to look for the greatest common factor first. And as we take a closer look, what we see in both of these terms is that there's a t squared. So let's factor out the t squared. And we didn't do anything to the s's. And remember, we had 2 t's, we took them out. We didn't do anything to the 4, we had 2 t's, we took it out. So once we take out the greatest common factor, then we can deal with this problem Another issue, however, is that it's s to the fourth, and you may or may not have dealt with any of that in a previous class. But it can be factored. And remember, when we split these up, we want the same values in each. So to split up s to the fourth, let's do s squared times s squared. And just a reminder, s squared times s squared, when you multiply with exponents, we add the exponents. 2 plus 2 is 4, so that's correct. And then when we break apart 4, square root of 4 is 2, and 2 times 2 is 4. Difference between two squares, different signs. Watch out for the greatest common factor. It applies to all of the methods. And as we take a look at problem number 18, when we look at this one pretty close, we're like, yeah, we've got 1, 2, and we've got a minus. But 32 isn't 16 times 16. So we need to ask ourselves, do we have a greatest common factor? And we do have a greatest common factor. The biggest number that divides into 32 and 8 is 8. And when we factor out that, 32 divided by 8 is 4. 8 divided by 8 is 1. We still have 2 terms and a minus. So now we can finish this difference of 2 squares. Square root of 4 is 2. Square root of n squared is n. Difference between 2 squares, different signs. Once again, every single factoring problem we do, we should glance at it at first and go, do we have a greatest common factor? And as we glance at this problem, we do have a greatest common factor. In fact, we've got the biggest number that divides into 2 and 50. That's 2. And when we look at some of the variables here, we've got a y in the first term and a y in the second term. Greatest common factor is y. We have 4 z's in the first term, and we have 2 z's in the second term. When we're dealing with variables, we take out the lowest exponent. So there is our greatest common factor, but don't stop there. 2 divided by 2 is 1. We had 1y, we took it out. We had 4 z's, we took out 2 of them. We still have 2 z's. 50 divided by 2 is 25. We had 1y, we took it out. We had 2 z's, we took them out. So we have dealt with the greatest common factor, and now we're going to deal with the difference of 2 squares. So I'm going to write this a little bit better. Hopefully my z doesn't, there, much better. And then we're going to turn this into 2 parentheses. And remember what we're doing. We're taking the square root of z squared, which is z. Z times z is z squared. 5 times 5 is 25. 5 is the square root of 25. Difference between 2 squares, different signs. We're kind of in this mode now of taking a close look and saying, well, do we have a greatest common factor? And between 200 and 242, we at least have a greatest common factor of 2. Those are both even numbers, so we can factor out a 2. We have a y squared in the first term. We have a y to the 4th in the second term. And when we're finding the greatest common factor of variables, we're dealing with the smallest exponent. Between z to the 5 and z to the 3, we want the smallest exponent, which is z to the 3rd, also known as z cubed. And let's see what we have left in here to see if we can factor any more than the greatest common factor. Well, 200 divided by 2 is 100. We had 2 y's, we took them out. We don't need any y's on this term. We had 5 z's, we took out 3 of them, so we still have 2. 242 divided by 2 is 121. We had 4 y's, we took out 2, we still have 2. We had 3 z's, we took them all out. And now when we take a closer look, the question is, can we do more? And we do have 2 terms and a minus sign, so the answer is yes, we can do more. We still have our greatest common factor, but we can turn this into 2 more parentheses. The square root of 100 is 10. The square root of z squared is z. Z times z is z squared. If you need to, use your calculator to figure out what the square root of 121 is, which is 11. And then the square root of y squared is y. Y times y is y squared. Difference between 2 squares, different signs. And hopefully you're getting the hang of it as we keep going here. When we look at problem 27, what we see is we have 1, 2 terms. This time we have a plus. That's different from all of the problems that we've done. And if you look back at your directions, it says if the polynomial is not factorable, write prime. There's a plus in here. We need to have 2 terms, which we have, and a minus sign. Difference of squares. Difference is the answer to a subtraction problem. When we look at 30, j squared, we can break apart j squared, but what we can't do, or maybe let me go backwards here for a second, 1, 2 terms, and a minus sign. So it looks like we can factor, and like I said a moment ago, j times j is j squared. K times k is k squared, but there's nothing times itself that equals 33. It's a big long decimal if you take the square root of 33. So this problem also happens to be prime. Watch out. Do you have a minus sign in the problem? Because you have to have a minus sign in the problem to do the difference of squares. Can you take the square root of everything? If you can, then you can factor the problem. But as we take a look at some of these final problems on our paper, once again, we need to go back to this idea of, do we have a greatest common factor? And when we take a look, at the very least, between 32 and 50, we have a 2. And if we take out a 2, there's no variables in common, but if we take out a 2, 32 divided by 2 is 16, a squared. And 50 divided by 2 is 25, b squared. But what we need now is we need to decide if we can go farther. 2 terms and a minus sign. We can go farther. 16 is 4 times 4. A squared is a times a. 25 is 5 times 5, and b squared is b times b. Same values in the parentheses. The only difference is the different signs. So hopefully at this point, you've really gotten into a routine. Looking for the greatest common factor, looking for the minus sign, taking the square root, and then what happens? Then I put a fraction in the problem. And I know that fractions aren't your friend, but just because there's a fraction in the problem does not mean that we can't factor this. And since there is a fraction in it, let's take it out. Let's make it the greatest common factor. It's not maybe technically the greatest common factor, but if we take out the 1/3, then we don't have to deal with the fraction anymore, and that's probably a better situation for us. So we would be left with -1, because 1/3 times 1 is 1/3. So the issue is, what's going to go in this spot right here? And this is where you might have to fall back on a little bit of algebra. And you probably don't have a lot of space on your paper. But here's what happens. If you take 1/3 times what number is going to give you 3? That's what we're asking ourselves. 1/3 times what equals 3? So we can solve this. We can multiply this side by 3, and we can multiply this side by 3. And what we're left with is 1x equals 9. So what's going to go back in here is 9l squared. Can't forget the squared. And then can we break this down into the difference between two squares? Well, I think so. 9 is 3 times 3. L squared is L times L. 1 is 1 times 1. Difference between two squares, different signs. It's going to be the same idea on the next problem. We've got a fraction in there, but since fractions aren't necessarily our friends so much, let's make the fraction the greatest common factor. So let's write that 5/4 out there, which would mean we're still left with -1 here. 5/4 times 1 is 5/4. But we have to figure out, well, what's going to be part of that first term? And it's the same idea. 5/4 times what number equals 5? We want to see what equals that when we're dealing with that fraction. Well, you can divide both sides. If you have a calculator, you can divide both sides by 5/4, but I don't have a calculator right now. So I'm going to multiply both sides by 4. We get 5x equals 20. And then we can divide both sides by 5. And we get x equals 4. That's the value that we're putting in here, 4b squared. And if you're not sure, check my math. Distribute. But you'll find that 5/4 times 4 does equal 5. And then, can we factor the difference between two squares? Well, 4 is 2 times 2. V squared is v times v. 1 is 1 times 1. Difference between two squares, different signs. And finally, to finish here, when we look at problem 42, once again, we should always be asking ourselves, do we have a greatest common factor? And the answer on this one, it's not obvious, but the answer is still yes. It actually is 17. If we factor out a 17, we're left with 5p squared minus q squared. And the thing is, we can't break apart 5. We can break apart p. P times p is p squared. Q times q is q squared. But we can't say 2.5 times 2.5 is 5. It's not true. Is this problem prime? It is not. Because we can take out a 17, we have a greatest common factor. We can't do much on the factoring front, but we can take out the greatest common factor. So this one is not prime.